Hello apes, this is question number 3 of the first practice exam FRQ. This is the one that we will do some math at the end, and so we'll go through it. Question 3A, preserving high quality agricultural land is important so that countries can grow enough food to feed their populations. Number 1, describe one agricultural practice that can lead to the degradation of agricultural land. There are an abundance of answers that you could have here. I chose a couple, but it doesn't mean that these are the only few that were right by any means. The thing that I really want to focus on here, though, is in describing it. First of all, only describe one. And when you describe, think about it as right here, you're gonna name it, you're gonna tell what it is, and tell what it does. So, for example, plowing and tilling the soil breaks up the soil structure and increases soil erosion and reduces fertility. So I named it plowing and tilling. I told you what it was. It breaks up the soil, and I told you what it does. As far as degrading the land, it increases soil erosion, reduces fertility. Another example would be monoculture. Growing only one crop deletes soil of nutrients. Or deplete soil of nutrients is actually probably a better word there. Overgrazing of livestock will eliminate soil-covered crop, which increases soil erosion. You also probably could add in here, it decreases soil compaction. A couple other ones might be clearing of a field, so reducing a cover crop leads to soil desiccation. Concentrated animal feedlots, so CAFOs, are going to be raising an abundant amount of livestock on the land, which leads to the compaction of soil from animals. And so there's a variety of answers that you could have here. I think the big thing is just that when you describe it, name it, tell me what it is, tell us what it does as related to the question. 2 asks to describe a potential solution or technique that can prevent the reduction, degradation of agricultural land. My suggestion would be whatever you said in the first one, talk about a potential solution to that. It doesn't have to be, though, in this case, because it's not saying that exactly. And so here, go back to, land use. When we looked at land use, I would not worry about memorizing all of them. I would hang on to a few of them for situations like this, so you can capitalize on the ones you really feel comfortable with. One example would be contour plowing. This is using the slope of the land to reduce soil erosion. Another would be no-till, not disturbing the soil, which increases organic matter and decreases soil erosion. So again, I'm going with the whole name it, tell me what it is, tell me what it does. Windbreaks, planting rows of trees or shrubs to protect an area from wind erosion. Perennial crops, so leaving crops on the soil year-round can improve soil structure and reduce soil erosion. Using a cover crop, so using a crop in between planting seasons to protect the soil, which will improve soil nutrient and prevent erosion. Crop rotation, that's a great one in Iowa. Crop rotation, rotating different crops over the same season or in different seasons, is going to prevent the depletion of nutrients and increase soil fertility. And so any of those types of answers. Rotational grazing involves moving animals through a series of pastures, which benefits the grass, decreasing soil compaction. And so there's a variety of answers here that you can use. I would really kind of capitalize on what are some of those good land use practices and just really feel confident with maybe knowing one or two of those really well. Question B is going to ask about a less developed country with a rapidly expanding urban population is concerned that its growing urban population will eventually expand to a level where there would not be enough land to grow the food it needs to support its population. B1, excluding importing food. So it's telling you we don't want to say import food. Excluding importing food, propose a solution to address the concerns of reduced land on which to grow food. And so if I come right here, I would probably start, since I'm proposing a solution to address the concerns of reducing land on which to grow food, and then would be by maximizing productivity by using GM crops to increase yield per acre. Or a solution to address the concerns of reduced land would be to use vertical farming techniques, growing up rather than occupying more square footage of land. You could also, another proposal would be to reduce population growth. So not only could you talk about maximizing yields and getting more per square hectare, you could also go the other route with education and family planning and talk about reducing slowing population growth through education and increased family planning. And so there's two directions you could definitely take there. I would maybe read and look at kind of the other questions to decide which avenue they're really focusing on. But either one would be absolutely correct in this case. Sorry. Looking at C, this is where we're going to get into math. Oh wait, I didn't do the B2. So B2 then, this one actually wants you to propose a solution to, or for your solution, explain a potential advantage of it. And so this you have to go, this one goes directly with whatever you say before. And here, I didn't give you an actual answer because there's so many that you could use, and it has to go with whatever you were talking about before. So here what they're really going to be looking at is any advantage to that solution. So advantages are always going to be things like improving yield, in order to reduce the amount of space needed, reduce the amount of land use, reduce the amount of waste produced, reduce the amount of pollution reduce the amount of fossil fuels combusted by reducing the amount of space used to produce crops. So there's a whole variety of things that you could use here. Just make sure that you're explaining how your solution in the previous question provides an advantage and what that advantage is. So what's that benefit? All right, now going on to C. There's a table here. A table for population size in a country is shown below. Population size is from 2009 to 2017 in millions. And we're just going to look at those numbers and calculate some different things with those numbers in that population. So number one, based on the table, calculate the percent change of the population size in this country between 2009 and 2017. And so I'm going to take the end population, which is 4.6, minus the start population, which is 2.7, and I'm going to divide that over the start population because I'm looking for a percent change. I have to take what it ended minus where it started divided by where it started, and then I'm going to take it times 100 because I want it as a percent. Now, this is something, unless they tell you specifically, I'm under the belief that you could round this. For example, over here, I used one significant figure past the decimal, and so over here, I believe that you could take 70.37% and round it to 74.4. In the actual key that I was given, it did say that you could round that even to 70%. However, I would make sure that whatever you're using in your calculations, would keep that many significant figures. And so my suggestion would be to use the 70.4% in this case. And so this answer right here is the one. Now you're going to get a point for the setup and you're going to get a point for the solution. So if you simply just put the solution because you've done the problem on paper, you're not going to get full credit. And so please keep that in mind. You have to, and you're typing it in, right? So you have to be able to type in the setup and then the solution. And so you're going to want scratch paper just to kind of get it worked out, but you have to make sure you give both or you will only get half credit. Looking at D then, the average person in a country needs 2,450 kilocalories per day of food to meet their full nutritional needs. The average number of kilocalories per hectare produced from available food in the country is 15,737,000 kilocalories per hectare. Question 1 is asking you to calculate the amount of land that would be needed to produce enough calories to feed a person for 1 year in this developing country, and show your work. And so this one is in red. Okay, so right here we're in red. You're again going to get a point for the setup, and so you're going to get a point for showing me this big setup, and then you're going to get a point for the solution. And if you want to use exponents, you can, or you can not. And so let's just take a look. It says that you're going to get 2.45 times 10 to the third kilocalories per person per day. You're going to take that times 3.65 times 10 to the second days, or 365 days per year. And so now we can get rid of our days. And then 1 hectare is going to actually produce 15,737,000 kilocalories, or 1.5737 times 10 to the 7th kilocalories. And so then you're going to be able to get rid of this. And then we are going to be able to go through and actually then calculate that answer, and you will find that you get 0.0568 hectares per person per year. And so you see that we have hectares per person per year. That would be the correct units. And so that would be 5.68 times 10 to the negative second hectares per person per year. And then the last question is calculate how much land would have been needed to feed the population of this country in 2017. Now here's the thing, if this answer is incorrect, then you really can't get the last answer correct. However, if you do the last answer, if you calculate the last question correctly, but you use an incorrect answer that you got in the preceding calculation, they will still give you points, okay? So don't think that just because you did this wrong, you're not going to get this. So if this is confusing to you and maybe you struggle with it, then whatever number you get, plug it into this last piece. So you're calculating how much land would have been needed to feed the population of this country in 2017. Well, in 2017, we have 4.6 times 10 to the 6th people, because it's 4.6 million people. You take that times the 5.68 times 10 to the negative second hectares per person per year. And in this, you will get that you will need 261,400 hectares, or 2.614 times 10 to the 5th. I actually have that written incorrectly in there. Now that I'm looking back at that, I'm not sure why I did that. This should not be negative, it should just be 5th. So this should be times 10 to the 5th hectares. And that is what you would need to feed this population in 2017. Hopefully this helps.